Welcome to qnawire.
Hi, so over here we're given the following figure in which the force of V is going to be equal to 0, and we're told that the angle theta A is equal to 84 degrees. So the force diagram for this situation is going to look like this. We're going to have our coordinate system, x and y, and on the y-axis we're going to have, acting going down, the force of the weight, that is minus mg. We're going to have acting up, the normal force, and the force that is acting on our system would be on this direction, would be FA, with the angle theta over here. Remember that due to the geometry, whenever we have a line that is crossed as such, let me put it down here below, actually over here. Whenever we have a line like this, the angle theta over here is the same as the angle theta over here. So that's why we can relate it directly as this. So the sum of the forces on x is going to be the one that generates an acceleration. So this is going to be mass times acceleration on x. This is going to be equal to directly Fa times cosine of theta A. On the other hand, the sum of the forces on y needs to be equal to 0 because the mass is not going to go up or down directly because we're going to have the surface. And this is going to be equal to the normal force minus mg minus Fa sine of theta. So in this case, if you're asked later to find the normal force, you can employ this equation and it would be equal to mg plus Fa sine of theta. In this case, we're concerned about the acceleration of the box. And since the acceleration is only going to depend on the x-coordinate axis, we're going to have that the acceleration is going to be Fa times cosine of theta A divided by the mass. The force acting is 18 newtons. The angle that we're going to have is going to be 84 degrees. And the mass is equal to 6 kilograms. So what we're going to get over here, up to two significant digits, is an acceleration of 0.31 meter per second squared, which is going to be our final answer.